Okay, we're going to back up from the computer graphics and we're going to come back to a simpler function. So let's consider this 1D function. So this is sampling. So sampling just means we're going to look at the value of this function in particular locations, right? We have a continuous function, and then we're only going to look at some discrete values of this thing. This is what we mean when we say that we're going to sample. It just means we take measurements out of the signal. Now, if we have these measurements, we're going to go try to reconstruct the signal. And by the way, here's a place. You've seen it before, right? So audio files, you probably hear that like they're sampled at 44 kilohertz or they're sampled at 11 kilohertz. That means that out of the continuous waveform of the music, we measure what's the amplitude of that waveform at specific locations. And in this case, we measure it at 44 kilohertz. So this is a place you may have seen this sampling term before. So sampling, what is sampling? It just means we discretize. So we're going to write a loop, we're going to evaluate our continuous function, we're going to store a vector of what are the outputs of this thing, right? We're going to store it in some discrete samples of that point. And this could be 1D, 2D, 3D. We're drawing 1D because it's easy to draw on the slides.